Blog Talk Radio.
Welcome to another conversation. My guest today is Peter McCarthy. He was born in Ocho Rios, Jamaica, attended Ocho Rios High School, studied automotive mechanic. He moved to the U.S. and researched in wind and solar technology. Currently, he's sales rep for a company in Minnesota. As usual, my co-host is Chris Daly, blogger at Jamaicans.com under Me Thinking Are You. Chris, take it away.
Thanks, Denise. And Peter, welcome to our conversation this afternoon. It's good
Thank
to
you,
have
Chris.
you.
Thank you. It's good to have me in the studio with you.
Yes.
Yeah.
As you say here, you're from the Ocho Rios region of Jamaica?
Yes,
Is that
I was
where
born.
your family is rooted?
Yes, I was born in St. Ann, Ocho Rios, Jamaica.
Uh-huh.
My dad was a truck driver, and I attended the Ocho Rios High School.
Okay.
I started at automotive school in Marvin's Park.
Okay.
And I like automotive engineering, but right now I see where I can do a lot to the planet, and I can save a lot of money and save the planet in general from consuming a lot of intake of fossil fuel by renewable energy.
So you went from a family structure that was pretty much invested in fossil fuel technology to now you being on the cutting edge of alternative fuels. So green energy. Why should we care so much about green energy? What's the philosophical justification?
Okay, in 1888, the wind turbine was invented.
Uh-huh.
And since then, there are a lot of new technology that has been added to the wind turbine technology engineers.
Okay.
You've got several different types of wind turbines. You've got wind turbines that are vertical axis and that are horizontal. Now, the vertical axis wind turbines that have been made now is that you can use one vertical axis wind turbine, and on that one pole, you can stack 3 sets of generators.
Mm.
Yes, with the horizontal axis wind turbine, you would have to have 3 separate turbines to produce the same amount of megawatt that you can do with one vertical axis.
Okay.
Yes.
So the vertical really is a pretty efficient system. How about
Definitely.
solar energy?
Solar energy. In 1883, Charles Phillips, I think he was a Frenchman, he created a solar cell.
Oh, in 1883.
In 1883, Charles Phillips, yeah. And from then there, they go on to making solar panels. And right now, the best solar panels, it's the N-phase solar panels. And Israel has the solar dish that in the middle of the dish, there is a magnifying glass that concentrate the energy in the middle of that dish,
okay,
where there are solar cells. Now, it's very, very powerful because it follows the sun as the Earth axis move around.
So it's a dynamic system.
It's a dynamic system.
Okay.
With the solar panel that has N-phase inverters, each panel has an inverter. With the old system, you have a set of solar panels that you would have to hook all those panels up into an inverter. But these new panels with the N-phase inverters, how they operate, they send AC current directly into your switchboard or your breaker box. And then from there, they have a monitor system that can actually tell you each panel, if you have 24 or 100 panels, what they're doing. One panel should break down or something should go wrong with one of the cells. You can identify it out of 1,000 panels because of the inverter that is mounted on that separate panels.
I see.
Yes.
That's neat. So how would give us a sense of what the energy situation is like in Jamaica and why we should consider make these technologies so attractive to Jamaica?
Well, first I can point out some locations in Jamaica that there is nothing that can grow. We can't grow no crops.
Okay.
Or nothing of any kind. But it can save the country millions and millions of dollars. It's on the North Coast area. It's from Rockabessa to Galena to Port Maria. Now, Galena has a lighthouse, and there's just pure coral reefs. Acres and acres of pure coral reefs. Stone. Yes. If the government in Jamaica or whosoever that are making electricity down there invested money in that area with wind and solar panel, it would create jobs. It would save money from buying diesel oil, and it would save the carbon effects of pumping a generator that is running from a diesel fuel. We are getting credit from a carbon footprint that if you have a country that has more green power technology, it's less tax that you will actually pay, because the other country that, like say, another country that is away from Jamaica that has more fossil fuel that is going out into the ozone layer, they will pay a higher rate of tax.
You mean this is the cap and tax scenario?
Right.
If that was implemented globally.
Right. It's implemented globally, right. So countries like Denmark, Spain, they're way ahead of us here in the U.S.
Okay.
There is another thing again. It's like Portmore. It's a very, very large community. And there are highways that run from Mandeville into Kingston.
Right.
Yes. On those highways, there are so much wind that is being created by the traffic. Yeah. They can build vertical access tunnels that will capture the wind from the highway and generate megawatts on top of megawatts on top of megawatts of electricity. Put that electricity into a smart, I don't know if it's there in Jamaica yet. It's called a smart grid.
Right, right.
So when everybody returns home back into, say, Portmore, Mandeville, Old Harbor, and all those places, there is enough electricity there to stop the constant power cut by load swings.
Right. So it would normalize and give you a more stable energy supply.
Exactly.
So there are two issues with power. There's one of generation, and then the second component is transmission. You've addressed the generation piece of it. How do you see the transmission being able to affect areas that may not have wind or are not have the concentration of wind or solar capabilities? Okay.
We've got sunlight most of the time in Jamaica.
Uh-huh.
Okay. If the guys down there that are producing electricity, that are JPS that are selling electricity, they should pay close attention to fuel cell batteries.
Okay.
Fuel cell batteries like ZES, it's ZBB or ZBB.com or BBB.com.
Mm-hmm.
There are huge fuel cell batteries that can store a lot of energy. And those fuel cell batteries can be used in peak shaving times when the demand is there, like in Christmas, in the holiday season when most people are home and they're using all the electrical appliances,
mm-hmm.
and when party goes on and the demand of electricity is heavy, they can use these fuel cell batteries that can be moved from one section of a community to the next section.
Okay.
Say like in Kingston at the stadium, they're going to be having a week of some form of Olympic Games.
Yeah.
Where they're going to use a lot of electricity. These fuel cell batteries, instead of depending on JPS and overloading the system, is take the fuel cell batteries, do a calculation, say they're going to be consuming 5 or 10,000 or 15,000 kilowatt hours for the week. They take these batteries in, load them up on a trailer, and plug them straight into the stadium electricity. So
into
actually you add into that grid.
Mm-hmm.
And on top of that, you can use a wind turbine in an area. If you can find like 2 buildings, you can use a vertical access wind turbines
mm-hmm.
that actually charge those fuel cell battery, and you can use solar panels.
So these are like large capacitor to be able to absorb the current, the energy, and use them in a mobile fashion.
Definitely. That is what they do here in the United States at these stadiums.
Ah.
Yeah, like the stadium downtown in Minneapolis, they're going to be having a huge, because those lights take a lot of electricity.
Right.
So what they do, they have the amount of calculation already, how much electricity the stadium is going to use. So what they do now, they take these fuel cell batteries that comes in 50 kilowatt hours, and they will put 10, 20, 30, and stack them and plug them into the stadium electric system.
That's wonderful.
Yes, and then they will have like solar panels. They will have biogenerator. Now the biogenerator, it's when you have like cooking oil that you use.
Mm-hmm.
Filtered cooking oil can be poured into a large generator that triple cell charge a huge battery bank. Those can also charge the fuel cell battery that will create a lot of electricity. These fuel cell batteries, instead of changing batteries like every 10 or 15 years,
mm-hmm.
these fuel cell batteries has plates inside. So when the plates go weak in producing the amount of kilowatt hours. Instead of changing a battery, they just go in and take the plates out and insert new plates in. That's another huge amount of saving.
That's wonderful. So so it's a recyclable energy system.
Exactly.
You've brought us so much energy and knowledge to the space. Where did you gather all of this information, and that you can speak with such authority on it, the subject?
I work for a company out of Savage, Minnesota, and I'll tell you something, Chris. I think I take this from my dad. I like technology, and I like technology that helps and make life easier.
Yes.
I am studying and I'm working on a software right now for the electric cars, because there's a lot of electric cars that will be coming down on the market, say within the next 5 years, 10 years from now. Those cars, Chris, will take all the kilowatt hours that it can run a whole complete city out of electricity.
Wow. Yes, I can just imagine. Yeah.
Yes, because of the amount of electricity that they have to take to charge them.
Yes.
So I'm working on something now, which I can't say over the air.
Okay, I understand. It's still in the before you get this idea patented.
Yes, I'm working on that, and some good other guys behind me.
Wonderful.
Yes. There is something that I would like to say. Did you know that they're doing a research on the roads? They're using the road to plant solar panels inside the road surface.
Okay.
That's going to go on somewhere in Texas and in California. That will generate a lot of electricity. Instead of having wires coming to your house, to the top of the house, the road will carry the electricity straight into your house.
So the road will be like the wires or that we now have. They'll be replaced by actually the road surfaces. Yes.
They did a study on glass. Glass is very tough, Chris.
Okay.
Glass. It's very hard. They can temper glass that a truck that is carrying 200 tons can run on top of it.
And it won't, shatter.
It won't break. I'm going to give you an example. Look at a bulletproof glass.
Yes.
You see how tough glass is?
Exactly.
Very, very tough. Yeah, they're working on the technology, and they're making very, very good stride on that.
Well, the technology is so very promising, and I'm thanking you for keeping us on the cutting edge. Part of the challenge is how do we pay for this? And one of the ways some folks are doing is using tax incentives for people to adopt the technology. Can you speak to how the cost side of the issue?
For people to adopt to the technology of
we have all this new technology. It's a new infrastructure that we need to put in place. And so there's going to be a cost associated with, redoing the roads, putting in smart grids and the like. What some folks are doing are using tax incentives to allow people to adopt the technology. Because of the cost, some people shy away from actually taking advantage of the technology. But some governments are using tax incentives to get people to actually, like if you can do your home and stay on top of your roof and generate, say, electricity through solar, and you can sell that back into the grid.
Oh, yes.
Installation of that solar equipment.
I know exactly what you're talking about. That is what I think we should do in Jamaica, not tomorrow, immediately. Because if the government down there starts doing tax incentives, it will get a lot of business entrepreneurs to invest there and create jobs and create money. Because I'll point something out to you. If you have a business that at the end of the month you pay, I'll tell you, the hotels in Jamaica are paying high amount of money for electricity at 36 US cent per kilowatt hour.
Yes.
Yes.
And right, it's about 8 to 9 cents here, right? Just to give people an idea. Is that correct? It's about 8 to 9 cents per kilowatt hour versus 36 in Jamaica.
Exactly. Okay. It's too high. It is causing a drawback on people that is trying to invest there. You can't break even. Now, if the government should make a tax deduction from people who can afford to use green technology on their factories and on their business, it's gonna catch on.
Yes.
And I'll tell you who will be very, very beneficial on the end. It's the JPS. Because when your factory is closed and you have a 1 meg or whatever size megawatt turbine that is running the electricity or it's running at night and the factory is closed, what it does, it's putting back energy back into the grid.
Yes.
That is what it does. And also with solar panels. Because it's called net metering. If you have net metering, I don't know what rate, and I'm not gonna say, but we're paying 36 cents.
Right.
If you go to Jamaica and you set up a solar or a wind farm just to sell back the electricity, I doubt if they would pay that individual or that company 36 cents, US cents, for the amount of kilowatt hours that they're putting back into the grid.
Okay. So it has to be a private-public partnership that if investors should want to come and generate energy, it will make it an attractive option for them to invest.
Exactly. Very, very, very good. Have you ever heard about Bloombox technology or Bloombox energy?
No, I haven't. Tell us about it, Peter.
Bloombox energy. It's a company in Silicon Valley, California. This guy that invented that fuel technology, he used sand, white sand, bake it onto a piece of metal.
Okay.
And inside the stock of plates, it's like you can have, if in case you're using 200 kilowatt hours,
yes,
he makes that fuel cell with 225 kilowatt hours and sells you that electricity in bulk.
I see.
So it takes you off the grid, totally off the grid. What it does, pumps oxygen from one side of the cell and natural gas from the next side, and the change of the two gases inside the cell creates an amperage.
Okay.
And then you get your electricity from there.
This is
now. Oh yes,
it's a semiconductor with somewhat of a energy kick to it to multiply the power.
Yes, the pattern is in the ink.
I see.
The electrochemical are in the ink that is being sprayed onto the sand. Now, Google has pumped millions and maybe billions of dollars into it. They are buying this system, and Google has first put it on their office. Then eBay has planted a huge amount of it, and they're working very, very efficient. All you do, like every, say, 4 or 5 months, is take the filter out and change it, because it is sucking the air into a docking, and that is where it goes into the cells, and the chemical change makes electricity.
Wow. Maybe just to explain for folks, it's not just the Google offices. They have these Google server farms, the big computer systems that actually keep the data. That's where they're applying the technologies, I'm assuming.
Oh, well, that's a different thing. That is Google Power Meters.
Okay.
Now, the Google Power Meter, anybody can, the Google Power Meter should be installed into hotels. Anybody that is having to do with a large power factor of electricity that is running business, they should have a Google Power Meter installed into their business, because what that does, that can tell you, look, your foot is on the gas. You need to take your foot off a little bit and allow the car to cruise, because you will get down the road much quicker. The Google Power Meter, it goes into your rotor, the rotor that runs your computer.
Okay.
With a code into your phone or into your laptop or into a next computer anywhere in the world you are. You can be in Australia and you take out your iPad phone and look and see the amount of electricity, your office, your anything at all, your factory, any kind of business that you're running that is burning electricity, how it's doing, how it's burning the electricity because of this Google technology.
Technology.
Yes.
Boy, this is just fascinating information. We're coming up near the end of our time here, Peter. Is there a place you'd point people to get further information?
Yes. If anyone is interested, they can contact me at my email address. It's Peter McCarthy, and that McCarthy, it's McCarthy2@gmail.com.
Okay. That's why.
Or they can, yes.
That's Peter McCarthy2@gmail.com.
Yes.
Great. Do you have any parting words for our audience, Peter?
Yes. What I would like to mention to anybody that is doing business is that your business tells you what is happening in your investment. And if you go green, you will stay clean and save a lot of money. Green technology is the way that anyone in business should go.
Great. You're not even a great technologist. You're also a rhymer. Thank you so much for sharing your wisdom with us. And we look forward to exciting developments in this green technology. And I hope your wisdom fall in some great ears that folks can start making that kind of mental change in their thinking and great investment that we can reduce the cost of energy in Jamaica. Continued success to you, Peter.
Thank you.
If one more thing, if you'd like to learn more about Chris Daly, visit Jamaicans.com. His blog is Me Thinking Are You. If you'd like to learn more about Jamaican diaspora, go to JamaicanDiaspora.com. Thank you so much for spending some time with us, Peter. We really appreciate it. Okay, bye-bye now.
It. Thank you.
Guy knows nothing beats the versatility of a 90s era hatchback. You want trunk space? The whole thing is trunk space, giving you the ability to haul canoe-sized payloads with little more than a trusty old bungee cord holding down the hatch. And with over 400,000 parts and a little Napa know-how, you can keep your small utility vehicle running longer, stronger, because it's not quirky, it's ahead of its time. That's Napa know-how. Napa know-how.